Hello students, today we will study conic sections, a very important part of coordinate geometry. These include four curves, circle, ellipse, parabola, and hyperbola. Each one has unique properties and applications in real life. Conic sections are obtained when a plane cuts a double-napped cone. Depending on how the cut is made, parallel, slanted, or perpendicular to the axis, different curves appear. Circle, ellipse, parabola, and hyperbola are all born from this single idea.
Sir, so the cone is the parent and these curves are its children?
Exactly. That's a good way to remember. A circle is the simplest conic. It is the set of all points equidistant from a fixed point called the center. Here you see point C marking the center. For example, if the center is at 0, 0 and radius is 5, the equation becomes x squared plus y squared equals 25. Now look at the ellipse. For any point on it, the sum of distances from two fixed points, called foci f1 and f2, remains constant. An ellipse has eccentricity less than 1. A famous example is planetary orbits. Planets revolve around the Sun in elliptical paths.
Sir, is a circle also an ellipse?
Yes, when both foci merge into the center, the ellipse becomes a circle. Next is parabola. It is defined as the set of points equidistant from a fixed point F, called the focus, and a fixed line D, called the directrix. It has eccentricity equal to 1. One common example is the path of a ball thrown in the air. It follows a parabolic trajectory. Finally, the hyperbola. Here, the difference of distances from two foci f1 and f2 is constant. Notice the two opposite branches. Its eccentricity is greater than 1. In real life, cooling towers of power plants often have a hyperbolic shape for structural strength. Let us now see their equations. For a circle, open bracket x minus h, close bracket squared plus, open bracket y minus k, close bracket squared equals r squared. For an ellipse, open bracket x minus h, close bracket squared, divided by a squared plus open bracket y minus k, close bracket squared, divided by b squared equals 1. Similarly, parabola, y minus k equals a times open bracket x minus h, close bracket squared. Hyperbola, open bracket x minus h, close bracket, squared over a squared minus open bracket y minus k, close bracket squared, over b squared equals 1. These forms help us draw graphs and solve questions.
Sir, will these equations always hold true?
Yes, provided the axes are aligned with symmetry. If the axes rotate, we use general forms. Another way to understand conics is through eccentricity. For a circle, E equals 0. For an ellipse, E lies between 0 and 1. For parabola, E equals 1. For hyperbola, E is greater than 1. So eccentricity is like an identity card of a conic. To simplify calculations, we also use parametric equations. For circle, x equals h plus r cos theta, y equals k plus r sin theta. For ellipse, x equals h plus a cos theta, y equals k plus b sin theta. For hyperbola, x equals a sec theta, y equals b tan theta. These forms are very useful in trigonometric substitutions during exams. Each conic has distinct properties. Circle has no asymptotes and is perfectly symmetrical. Ellipse is closed, has two foci and no asymptotes. Parabola opens infinitely in one direction. Hyperbola has two open branches and asymptotes crossing at its center. The general equation of a conic is a x squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Any curve satisfying this belongs to conics. To identify which conic it is, we check discriminant b squared minus 4ac. If less than 0, it is an ellipse. If equal to 0, it is a parabola. If greater than 0, it is a hyperbola. So the discriminant acts like a judge. Conics are not just theory, they are everywhere around us. Circle, wheels, gears, radar systems. Ellipse, whispering galleries, orbits of satellites. Parabola, car headlights, telescopes, projectile paths. Hyperbola, navigation systems, radio transmission, cooling towers.
Sir, why are satellite dishes shaped like a parabola?
Because a parabola reflects all signals parallel to its axis directly to the focus. That ensures clear reception. So students, today we learned how all conic sections are connected from circle to hyperbola. They are not only beautiful in geometry but also essential in science and technology. Keep practicing their equations and properties. That's all for today. Jai Hind.